Example 9 states that if one of the roots of the equation 2x squared plus kx plus 25 equals 0 is twice the other, find the possible values of the constant k. So we know that one root is double the other root. And we know those other things from before. Again, if you can remember, alpha plus beta is negative b over a, and alpha times beta is c over a. So we're using these to help figure this out. So we know that one is twice the other. So if we want to try to figure out a root, how can we do that? Because we're going to try to find one of these roots, and then we're going to use that information to help find what the value k is. So we need to figure out one of the roots first. Since we don't know them, what we need to use is we need to avoid the k at first. We need to try to figure out how can we get this to work without that. And so we have an obvious use if we use c and a. So we can figure this out pretty quick. So if I know that one root is double the other, so I'm going to say there's alpha, and then beta, if it's double alpha, I'm going to call it 2a, or 2 alpha. Now that equals c over a, which is 25 over 2. Okay, so we're at this point. So now we can simplify and kind of do some algebra. So 2 alpha squared is the same thing as 25 halves. So we're going to continue. So this means that alpha squared, so if we divide by 2 on both sides, we're going to get 25 over 4. And we know that alpha squared is going to be the positive, or excuse me, alpha is going to be the positive or negative square root of 25 over 4. And so when we do a square root of something like this, we can take the square root of the top and bottom separately. So we're going to end up with either a positive 5 halves or a negative 5 halves. So either of these are possible for what we're looking for. Now, what we want to do is now kind of move on and try to figure out, okay, well, how do I figure out what k is? Okay, so k represents this negative, this b value. So I can use that to help figure out where to go from there. So I'm going to move down the page. So I know that the sum of my roots, again, so I've got alpha plus 2 alpha equals negative k over 2. So that's just what we had before. So what we can do here is try to figure out how do we get this to work. So this is 3 alpha makes negative k over 2, and alpha is going to be negative k. Oh, excuse me. That's wrong. Just a regular alpha. Oops. Regular alpha is going to be negative k divided by 6. So there's 2 equations that I have. So I know that I can use, if a is 5 halves, I can say 5 halves is negative k over 6. Well, in this case, I can multiply the 6 over, and I'm going to get 30 halves, which is 15. So I'm going to have 15 equals negative k. So k could equal 15. I could also have negative 5 halves from before equals negative k over 6. And so this would be, negative 15 equals negative k. And so therefore k could be just 15 as well. Or this negative should have been up on the top, I apologize. So we could have k to be negative 15 or k to be a positive 15. Those are your 2 possibilities in order for this situation to work. So what you want to do is use those sum and difference equations to help try to fit what do you know at first. I know that I can find the product of them and figure out one of the roots possibly, And then I can go forward and say, okay, this is what k would be based off of using the other information.